So in this question, we're asked for, excuse me, the compression factor and the molar volume. So I'll just refresh your memory with the question. The gas at 350 Kelvin and 12 atmospheres has a molar volume that is 12% larger than that calculated from the perfect gas law. Find the compression factor under these conditions and the molar volume of the gas. And finally, which are dominating in the sample, the attractive or the repulsive forces? All right, so here's what I'm given. The temperature is 350 Kelvin, the pressure is 12 atmospheres. And the molar volume is 12% greater than that predicted. So my little degree sign here stands for ideal. And so my compression factor is PVM over RT. Okay, but I can't calculate Z directly from this because while I know the pressure and I know R and I know T, I only know the molar volume is 12% greater than that predicted, but I don't actually know what it is. So I kind of have two unknowns here. So I go to my second expression or my other expression for the compression factor, and that is that as a unitless factor, it is also equal to the ratio of my observed molar volume to that predicted. So if it's 12% greater, then I'm just after the ratio, so I can use any number I want so long as I represent the ratio properly. So let's make that ideal or perfect gas predicted molar volume 1, and 12% greater would be 1.12 times that. So my compression factor is 1.12. So that's my answer for that one. And so then what is my molar volume? Okay, so now that I know what Z is, and I was given T, and I have R, and I was given pressure, now I rearrange this for the molar volume. So there we go. And so it is equal to Z RT over P. There's my Z. The R that I'm using, sorry, this is rather small, 0.08206 liter atmosphere per mole Kelvin, so that my temperature is in Kelvin and my pressure is in atmospheres. And I'll get a value 2.68 liters per mole, which are the units that I want for molar volume. And I then trimmed it back to just 2.7. The reason I did that was because I looked back, everything was multiplication, and so I can look back at my original data, and I'm limited by the 2 sig figs given in the pressure. So that's that. And finally, what are the dominating forces? Because my Z is greater than 1, my repulsive forces are dominating. So if I needed to sort of sketch for this gas, Z versus pressure, I would draw my reference point of 1.00, and I would say that since the dominant force is repulsive, my Z I'm predicting to be greater than 1. So that's how I would do that one. And then maybe I can do the last question here on the same video. And that is 4B. And 4B is, predicting the molar volume of the van der Waals gas. So let me read you 4B. Cylinders of compressed gas are typically filled to a pressure of 200 bar. So for oxygen, what would be the molar volume at this pressure and 25 degrees Celsius based on number 1, the perfect gas equation, but number 2, the van der Waals equation, and they give you the two constants. Okay, well, perfect gas, that's pretty easy. Perfect gas is equal to what? Van der Waals is equal to what? Here's the constants. So we can swing down here to answer 1. PVM is RT, so VM is RT over P, and everything gets put into the expression. All my units cancel, and I'm left with this value. Then for 2, what is the van der Waals? This is a little bit messy because this is the copy I used just, it was supposed to be just for me, for grading. But here's my cubic equation. So know that you don't have to memorize this, and again, this won't come at you on a test, but it's totally feasible for an assignment because we used to write little programs to solve these. Just like we have a quadratic formula, we have a formula that solves a cubic equation. So here it is in its form, cubic form. So Vm cubed minus V plus RT over pressure times Vm squared, and so on and so on. So the A's and the V are the van der Waals constants that are given. Just be careful when we've got negative signs to account for, because I think that's the only place where folks went wrong. This that has the circle around it is the coefficient of Vm squared, and that comes out to be this number. I'm carrying more digits than I need to because the calculation is not complete. A over P is my coefficient of Vm, and AB over P, pressure, is my last one. And so I want all of these numbers to fit the form of the equation, x cubed minus, instead of molar volume I'm using x, so x cubed minus this guy x squared plus this guy times x minus this guy. Okay, so I'm paying attention to the signs, and I have my equation online that I plug into my little program, and it says here's the equation: ax cubed plus bx squared plus cx plus d is equal to 0. So line that up, and they ask you to plug in your values for a, b, c, and d, and they'll give you the real root, and the real root was returned as 0.11169. Yeah, so that gave me a molar volume of 0.112 liters per mole. So again, it's just practice using that cubic equation, but we don't have to practice it in a way that prepares us to be able to do it on a test or exam because we use the online tool. And I just wanted you to be able to do that. So that's the end of that assignment. Hope this is helpful.